Hello, I'm Susan Knowlton and I'm with Corteva Agriscience. And Corteva is the world's leading supplier of high oleic seeds, including high oleic soybean seeds. And what I'd like to talk to you today is about high oleic soybean oil, a new oil on the market that has exceptional stability. When we talk about high oleic soy, we like to call it the reinvention of soybean oil. And that's because it's really that different. It's a soy-based trans fat solution that we developed specifically for the food industry. And we improved the nutritional profile of the oil. It's got about 76% oleic acid, 20% less saturated fat than commodity soybean oil, and of course it has no trans fat. It has enhanced functionality because of these changes to the fatty acid composition. So it's a very stable oil. For example, for frying, it gives you longer fry life and provides longer shelf life for packaged goods. And we won't talk about it today, but even though we developed it for the food industry, it also has uses in industrial uses as an environmentally friendly solution for preparation of industrial fluids. High oleic soybean oil was created to address the problem of oil oxidation. And oil oxidation is a complex set of reactions that begin with the double bond on unsaturated fatty acids. And the chemistry is complex, but it involves the primary oxidation reactions that go through a fat hydroperoxide, which then lead to the secondary oxidation products, including both volatile and non-volatile components. The volatile products can cause the development of objectionable flavors and odors, things that we associate with rancidity. And then the non-volatile components, polymerized and polar compounds, will cause physical changes to the oil, things like increased foaming and increased viscosity, and other physical changes to the oil as well. And so oxidation has real-world consequences that are problematic to the food industry with respect to poor sensory quality and operational problems as oils degrade. So most of you know that commodity soybean oil is rich in these unstable polyunsaturated fatty acids, and they're susceptible to the oxidation reactions that we just talked about. Now this next slide shows you the composition of high oleic soy in comparison to the commodity soy. First off, you can see that the oleic acid has been raised significantly, whereas in commodity soybean oil, oleic acid is around 22%. We've raised that up to about 76% in the high oleic oil. And likewise, the polyunsaturated fatty acids have been reduced significantly from over 60% in commodity soy to less than 10% in high oleic soy. We've also reduced the saturated fatty acid content by about 20%. And we did this genetically rather than using hydrogenation to improve the fatty acid composition of the high oleic soybean oil. That change in fatty acid composition results in a very stable oil. Comparing the stability of oils is easily done with a test called the OSI, or Oxidative Stability Index. And this test gives you a single number in hours, and it reflects the stability of the oil. The higher the number, the more stable the oil. You can see in this chart that the stability of high oleic soy is roughly 5 times that of commodity soy, with an OSI typically around 30 hours. It's also interesting to note that high oleic soy is quite a bit more stable than other high oleic oils like high oleic canola and high oleic sunflower. And these typically have OSI values somewhere in the high teens compared to 30 hours in high oleic soy. Thus, high oleic soy is one of the most stable oils available on the market today. And the reason for this exceptional stability is not only because of the change in fatty acid composition that was made, but also an effect of the beneficial antioxidants that are minor components of oils. Soy, including high oleic soy, has the highest amount of tocopherols and the right type of tocopherols to protect the oil from oxidation. Thus, it's the combination of the reduction of polyunsaturated fatty acids along with the beneficial tocopherols that give high oleic soy its exceptional stability. So we've talked a lot about the stability of high oleic soy. What types of applications do we anticipate? This slide shows you some of them. They're both liquid and solid fat applications, even though the oil itself is a liquid oil. In food service, frying is probably its biggest application, deep frying in particular. I'll show you examples as we go through the slides. But it's really one oil for the whole kitchen. Can be used in other ways as well, preparation of dressings, sauces as a pan and grill oil, for example. In food processing, it's similar. Frying is one of the biggest uses of the oil for a whole variety of different frozen foods. Snack food production, salty snacks, coating oil for nuts and candies, that sort of thing. In baked goods, either as an ingredient oil or as a spray oil, and also as a base oil for shortenings, and that's a particular application that we'll talk about in a little bit more depth. Non-dairy creamers is actually its biggest use in the US today. High Oleic soy can also be used as a retail bottled oil. It's a nutritionally optimal oil with a very bland flavor for situations in which you don't want the flavor, a highly flavored oil like peanut or olive. And it has the added benefit of your pots and pans will clean up easier. So let's talk in more detail about food service and frying in particular. The chart on your left demonstrates the longer fry life of high oleic soy when compared to commodity soy. Using 25% total polars, which is an internationally recognized endpoint for fry oils, you can see that the fry life of high oleic soy is 2 to 3 times that of commodity soy. And that translates to money in the bank for the restaurant operator who can use half the amount of oil that he or she would normally use. But flavor is king, of course, and studies have shown that foods prepared in high oleic soy compared to other alternatives is preferred in industry taste tests. What chefs and others have told us is that the flavor of the food comes through and not the taste of the oil. Another attribute users of high oleic soy value is the lack of polymer buildup on fryers and other pieces of equipment. Polymerization is a direct result of oxidation, and these polymerized materials coat the surface of equipment when unstable oils are used. The material is very difficult to remove. It's almost like a tarnish, and therefore oils which polymerize less will offer cost savings from either decreased maintenance, improved cleanliness, or overall reduced foaming. Comparison of polymer formation as indicated by viscosity increase among a number of different oils is shown on the right. You can see that high oleic soy is the least viscous, remaining completely liquid and looking virtually untouched, whereas many of the other oils, including the commodity oils, have actually solidified under the same heat treatment. And this just shows you the difference in polymeric buildup, commodity soy versus high oleic soy 12 days after frying. You can see on the left, the fryer basket is got a lot more polymeric material than the fryer basket on the right, in which high oleic soy had been used. And this next slide shows you the same thing, the interior of those fryers, same time, 12 days after frying. Commodity soy has a lot of buildup, and you can see very little on the high oleic soy side on the right. Let's switch gears now and talk a little bit about food manufacturing and the benefits that high oleic soy can bring to this category. And one of the largest benefits is the fact that high oleic soy can extend the shelf life for food for packaged goods. In this test, which is called the Schall oven test, you're looking at the accumulation of peroxides over time, an indicator of oxidation, and therefore you want to be the lowest line on the chart. And a good rule of thumb for the test is that 1 day in the oven is equivalent to about 1 month on the shelf. So you can see that high oleic soy is the lowest line on the chart. It's accumulating peroxides at the slowest rate compared to all of the other oils we tested, including other high oleic oils, palm oil, as well as the commodity oils. This translates into a cost savings for food manufacturer when their packaged goods have a longer shelf life. In the US, many food companies are trying to clean up their labels by removing synthetic antioxidants out of their food formulations. High oleic soy can help them do that. In this chart, you can see that unformulated high oleic soy alone is more stable as measured by OSI than commodity soy plus TBHQ, which is a synthetic antioxidant that is quite effective, but not a desirable ingredient on a food label. And even though high oleic soy is a very stable oil, if a food company wants to extend shelf life further, A natural antioxidant, which is labeled friendly, can be used to further increase stability. Now, another category that has seen a lot of success in the United States has been the use of high oleic soy for the preparation of shortenings, particularly significant in the baked goods sector. High oleic soy is a liquid oil, but it can be used as a blend component, as a high stability liquid oil coupled with a source of solid fat to create shortenings. Using interesterification, shortenings can be made which are lower in saturated fat and have improved handling characteristics compared to palm-based shortenings. And high oleic soy shortenings can be rich in stearic acid, a saturated fatty acid that does not carry the same negative health impacts that are associated with palm-based shortenings. And in fact, work has been carried out supported by the Qualisoy organization, which demonstrated that high oleic soy-based shortenings performed almost identically to partially hydrogenated soy-based shortenings and superior to that of palm in a variety of solid fat applications shown on this slide, including icings, cakes, and cookies. And in speaking of health impacts, it's important to note that a clinical trial has been conducted by David Baer at the USDA Human Nutrition Center, which demonstrated that high oleic soy provides for both improved functionality in food while still supporting healthy blood lipid profiles and reducing the risk of cardiovascular disease. Specifically, David and his colleagues found that high oleic soybean oil consumption resulted in similar lipid and lipoprotein profiles to that of commodity soybean oil for everyday use, and then when blended with a fully hydrogenated hard stock, the high oleic blend shortening resulted in improved lipid and lipoprotein profiles compared to that of a palm-based blend. And it's this last finding that's quite exciting, as many companies have been on a search for alternatives to palm for a variety of reasons. And this finding supports the use of high oleic soy in solid fat applications, which are absolutely critical to the baking industry. And it's this data, along with a lot of other data, that has led the FDA to approve a qualified health claim for high oleic oils in general, including for high oleic soy. And that qualified health claim reads that supportive but not conclusive scientific evidence suggests that daily consumption of high oleic oils may reduce the risk of coronary heart disease. I hope you've enjoyed this presentation. I hope you've learned something, and I thank you for your attention.